you a little bit of practice identifying a catalyst as well as the intermediates in reaction mechanisms. So the catalyst is present before and after the overall reaction. So you're going to see it on the reactant side and then on the product side. The intermediates are produced in an elementary step, usually the first or an early step, and then they are consumed. So you will see it as a product first, and then you will see it as a reactant in a lower elementary reaction. So in this example, we just have A's and B's. The overall reaction is A plus B gives us C. The proposed mechanism is as such. Let's identify the intermediate and the catalyst. So notice that we have Y produced, and then Y is consumed in the second step of the mechanism. So the intermediate is Y. For the catalyst, notice the catalyst is a reactant and it's a product. So the catalyst is X. Let's look at our next one. We're asked to determine the catalyst and the intermediate in the following proposed mechanism. S2O8, the name of that ion is called the thiosulfate ion. Sometimes it's called the persulfate ion. It reacts with iron 2 to give us the sulfate ion and the iron 3 ion. So, looking for the intermediate as well as the catalyst. So first, I see that Fe2 plus occurs as a reactant, and then it occurs as a product. So that is your catalyst. And then, remember, an intermediate is produced. So looking at iron 3, it's produced in my first step of the reaction and consumed in my second step. So my intermediate, and yours too, is iron 3 ion. Now with this one, let's go ahead and determine the overall reaction just for practice. So remember, we can cancel our intermediates and we can cancel a catalyst. So our overall reaction is S2O8, 2 minus. Again, that's called the thiosulfate ion. Plus, we have 2 iodide ions. Yields are 2 sulfate plus I2. You might recognize this as a redox equation. Just thought I'd bring that back to your mind. All right, our next one is a reaction. This is what happens up in the ozone. So this is the mechanism that destroys the ozone. When chlorine gets with O3, which is ozone, it begins to break it down. So again, let's determine the intermediate and the catalyst. And they just use the term species in this problem. Species just means either the ion or the element or the molecule that we're identifying. So looking at the first one, I see Cl, and Cl is present as a product in the second step. So that is my catalyst. So Cl is the catalyst. And in the next part, I see that ClO is produced, and then it is a reactant. So that is my intermediate. So ClO. Now, let's just write the overall reaction. So we have O3 from the first step plus O yields 2 molecular oxygens. That's that's it.